Welcome back to Smith Coding and Design. This is tutorial 4 for our microARC Vise fixture plate. So in this tutorial we'll get into Op2 and hopefully finish it. So before we jump into Op2, I did make a slight mistake previously on the drilling operation. So what we want to do is go back into our second drilling op where we use the 1/4 inch drill. And if we go to our heights, here I have hole bottom. And so the problem is if we use hole bottom, we won't go all the way through the holes in the center here where we mount our vise. So all we need to do is simply change this from hole bottom to model bottom and then go ahead and leave the 50 thousandths breakthrough and everything will turn out fine. So we'll click OK. And so now we'll go ahead and jump into Op2. So the first thing that we are going to do is we are going to go ahead and remove this top hat of material. So we'll kind of zoom in here. You can see that the stock updated from the previous operation. So all of our toolpaths from Op1, that's good. And here's the large hat material on top. So we're going to power through that with a Superfly. So let's go back to our home view and we'll start with a 2D face. We'll select our tool. We'll go ahead and use the Tormach Superfly from my 770 tool library. Now we're going to be slightly aggressive. We're going 2000 RPM and we are going to go 50 inches per minute. That gives us 25 thousandths per tooth. And again, this is, I consider it aggressive, and you'll see in the video it creates large chips and they sort of sound like popcorn hitting the enclosure. So look out for that if you're not expecting it. It can be slightly scary, but nevertheless, the toolpath works and you'll be fine. So what we want to do is now go to our heights and make sure our heights are fine. So we're starting with a bare stock and then we are machining to our model top. So stock top to model top is good for our first operation on the back side. We now want to go to the passes tab, and here we will adjust some of the parameters. So first of all, our step over, I'm going to change that to 50% the diameter of the tool, or 1.5 inches. I am then going to enable multiple depths. We're going to stay at 40 thousandths for our roughing step downs, and then I'm going to include a finishing step down, and we're going to go nice and slow on this finishing step down. So we're going to go 20 inches per minute, and then we are going to make that finishing step down 20 thousandths just to try to get us the best surface finish that we can get. Okay, so the last thing I'm going to do here is click extend before retract just to make sure the tool goes all the way off of the material before retracting and doing the next pass. So we'll click OK, and then we'll go ahead and simulate. All right, we'll slow it down a hair. And there you go. There's nothing to it really. We're just going back and forth and facing the top hat of material off. What I do want to do is we'll go to the front view here and we'll go nice and slow. I just want to make sure the tool goes all the way off the edge of the stock before doing the next pass, just to make sure we don't leave any tool marks, and it does. So I think we're fine. We'll make sure it does the same thing over here, which it should. All right, so that all looks good to me. So now we'll go back to our home view and we'll just speed it up here so we can get all the way through the toolpath. Awesome, so I'm not seeing any collisions. Everything looks good. And now we are to the bottom side of our part. It'll have a nice finish. Again, I love the Superfly. So now what we need to do, since we've faced our part, is go ahead and pocket the inside. So we'll go ahead and do that now. So we will click on 2D pocket. We're going to use the same 3/8 Gorilla Silverback 3-flute end mill that we used in Op1. So we'll select that. We are at 7,500 RPM. We're going to go 50 inches per minute. And that gives us right around 2 thou per tooth. The next thing we're going to do is go into our geometry tab, and we are going to select the center face here where we want the pocketing toolpath to be. We will then go into heights, and here I see a problem. Our top height should be the model top, since we went ahead and already removed all the material off the top of the model from the first facing operation. Now we will get into the passes tab. Again, I'm going to make the step over 50% the diameter of the tool. Okay, I'm going to enable finishing passes, and I'm going to make that finishing pass 10 thou, just so we go through and finish the sidewalls after we're done with the pocket. And I'm going to use a finishing overlap of 50 thousandths. And then I'm going to go down here and uncheck stock to leave, but I am going to enable multiple depths, and we are going to make our roughing step down 50 thousandths. So we are going to be pocketing 50 thousandths at a time in terms of depth of cut. All right, that looks good there. The next thing I'm going to do is just enable smoothing and feed optimization. And then we'll go over to linking, and what we want to do here, again, I always change my lead-in sweep angle to 45 degrees. And then more importantly, if we go here to the ramp clearance height, it starts 100 thousandths above the stock. We don't want to cut all that air, so we're going to start 20 thousandths above the stock, above the top surface of our part, and then do the helical entry. Okay, so that looks good. We'll click OK. And then again, we're just going to right click and simulate. And then we'll use the timeline here so we can see the helical entry, and then we just simply pocket out the center of our part. And I'll just sort of drag through here so we don't waste a lot of time. So everything looks good. And then we should get to the edge here and do our finishing pass. Beautiful. Okay, so that toolpath looks fine. Happy with it. So the next thing we want to do is go ahead and do the pockets here for the countersink, so that our M6 socket head cap screws will go ahead and fit inside and mount to our vise from the underneath side of our part. So we'll go ahead and do that now. Okay, so we're going to go to 2D pocket, and this time when we go to our tool library, we are going to select the 1/8 inch 3 flute Shars and mill, the same one we used for Op1. We'll select OK. We're going to be conservative here. We're going 8,000 RPM, and I am going to go 25 inches per minute, and that should put us right around 1 thou per tooth. Good. So now what we'll do is we'll go into our geometry tab, and what we want to do is just select the bottom face. So we're making room for our socket head screws. That way we can mount the vise from the underneath side of our fixture plate. So there we go. We have our surfaces. We'll go ahead and go back to the home view, and then we'll go to the heights tab. And what we want to do now is use model top instead of stock top. Okay. And then we will go into the passes tab. Here I'm going to enable finishing passes, and we want this to be 10 thousandths. I'll go ahead and add a 50 thousandths overlap. And then again, we're being conservative, so I'm going to go with 15 thousandths for our roughing step over. So let me just zoom in here and show what's going to happen. Again, similar to Op1, we're going to plunge into the center of these pre-drilled holes, and then we're going to go ahead and perform our pocketing operation at full depth of cut, which would be 1/4 of an inch with this 1/8 inch end mill. So we'll now go back to our home view here, and what we want to do next is we don't want to leave any stock, so we'll uncheck that. We don't care about multiple depths. We're going to do the full depth of cut. And so we will enable smoothing and feed optimization. And really the last critical thing that I would like to do is go to the linking tab and then scroll down the pre-drill positions. we'll click it again, and then we'll go ahead and click all of our holes. And so this will allow us to again plunge into the center and then perform our pocketing operation. So we'll go ahead and click OK. Fusion generates a toolpath. Now what I want to do is simulate, because there are a couple disasters I want to make sure we avoid. So we'll use the timeline. So the first thing we want to make sure is that we do indeed plunge into the center of our hole and not into this little sliver of stock that's left or into our model. So that looks good. The next thing I want to make sure is that the tool holder doesn't make contact with the top of our part. So I'll go ahead and use the timeline again and just make sure. So looks like we're not making contact with the top of our part. We're well above it, so that all looks good. So what I'll do is I'll just go ahead and drag the timeline, and then we'll let it play out from here. So there we go. Everything looks good. And so next what we'll do is we'll go ahead and perform a 2D chamfer and just clean up any burrs that are around any of the edges and make sure that they are not sharp. So we'll go back to our home view, and we will do that now. So what I'm going to do is just go to 2D, and I'm going to select chamfer. There it is. And now what we'll do is we'll go select our tool. We'll go to my Tormach library, and same thing that we did with Op1, we're going to use the 1/4 inch lemur chamfer. Select OK. It's from Gorilla Tools. 4,000 RPM, 20 inches per minute. I'm okay with that. And that leaves us right around 1 thou per tooth. We'll go into the geometry, and I want to select all of the mounting holes. And then we want to select the inner contour and the outer contour. So we go ahead and we chamfer everything. We'll then go into our heights tab, and again, the top height, we want to make that model top, and you can make the retract height model top as well if you would like. So what we'll do now is go ahead and set the chamfer width. So I'm going to make my chamfer 10 thousandths. And then I will just enable smoothing and feed optimization and go into linking. Okay. And then I will make the lead in sweep angle 45 degrees, and that should go ahead and do it for the chamfering toolpath. So we'll click OK. And then what we want to do again is just right click and simulate. So let's make sure we're not going too fast. So there we go. We're going to start by chamfering the inside contour. Speed it up a little bit, the outside, and then we'll go ahead and finish off all of the mounting holes. So that does it for the microARC fixture plate. That's the end of Op2. Hopefully you enjoyed, and hopefully you're finding the tutorials as well as the parts you would be making to have some use. I want to try to make parts that have some sort of utility and aren't just useless. So I thought that this would be a good tutorial. So let me know what you think in the comments, and like and subscribe. I'll see you guys in the next tutorial series. Thanks for tuning in. All right, so now we're going to start with probing our stock for Op2. Again, we're going to go in the Path Pilot, go to the Rec Circ tab under probing, and then click Define XY Center for the circular boss. So it's going to take a few minutes to do this. You can see the part is already flipped, and it's in the soft jaws. So we made those soft jaws in the first tutorial. So now we're just probing around the outside again just to find the XY center of our part, and then again we'll go ahead and probe the Z, which would be the top of our part. You can see that the top of the stock is shiny. That's because I prepped the stock, so I faced both the top and bottom side of the stock and measured the thickness of my stock with a caliper and entered that into Fusion 360 in the parametric model, as you saw from the first tutorial, just to make sure that I got everything right. I wanted this part to be rather precise, since I am going to be relying on it to hold my vise onto the microARC. So now we do the facing operation with the Tormach Superfly. We're moving 50 inches per minute, taking a 40 thou depth of cut. And again, our width of cut is 1.5 inches or 50% the diameter of the tool. It's a rather large cut, so you can see the large chunks or the large chips flying as we pound through the stock. And again, just be prepared for that if you haven't used the Superfly taking a decent depth of cut like this, or something like a shear hog. You might not be used to the chips hitting the enclosure and sounding sort of like popcorn. So just expect that, and don't be too alarmed. So now we're performing our first pocketing tool path. Again, 3/8 inch Gorilla Silverback, 3 fluid end mill, running 50 inches per minute, 50 thousandths depth of cut, and 50% the diameter of the tool in terms of width of cut. We're just going ahead and doing the centered pocket there, where our socket cap screws will eventually go in and hold our vise from the underneath side of our part. Okay, so now we perform our second pocket tool path. We're using a 1/8 inch Shards end mill, 25 inches per minute, 1/4 inch depth of cut, and 15 thousandths width of cut. We're making the counter sinks for M6 socket cap screws, or really they're counter bores, such that our socket cap screws again can mount the vise to our fixture plate from the underside. And finally, we finish off with a 2D chamfering toolpath. So we are using a 1/4 inch Gorilla Lemur chamfer, 20 inches per minute with a 10 thousandths chamfer width. And we're just going through removing all the burrs or any sharp edges from the inside contour, the outside contour, as well as all of the mounting holes. So that does it for the microARC tutorial. I hope it was useful. I hope you enjoyed it. Please leave any comments for any features or anything you think that I could have done better. We'll learn together. Please like and subscribe, and I'll catch you in the next tutorial series.